Imagine what would be your reaction if you check your results and it only says that results are good or bad. What would happen if you went for shopping to buy anything? The shopkeeper says, give me money more and more. What would be the reaction of shopkeeper if you just go and say, like, give me some rice? What he will give? What if heights were only measured as tall or short? What if someone like your parents buys for you some clothes, accessories, footwears without knowing the size? Confusing, isn't it? Now, this is all about our daily life problems or our daily life confusions. But what about scientists? They use many skills as they investigate the world around them. They make observations by gathering information by their senses. Some observations may be simple, like the color or observing the texture of any object. That is easy. But if scientists want to know more about any substance or any process or any phenomena, they need something else. Something that is very common, very simple, but very important. Yes, that is measurements. Now, in this chapter, that is chapter number 2 in physics part 1, units and measurements, we are going to deal with these topics only. Measurement is perhaps one of the most fundamental concepts in science, right? So let us go through this chapter and discover some important topics and things related to units and different measurements. Now, main topics in this chapter are, obviously we'll start with the introduction part. What is measurement? Why do we need measurements? International system of units we will see. We'll also see measurements and something which is crucial about length, measuring mass, measuring time, accuracy, precision and errors in measurements. Then we'll go for significant figures. You might have already covered this topic in chemistry chapter 1. Still we will continue with this. Then we'll go for dimensions of physical quantity. What are dimensions? How to represent dimension in form of formula, equations. Then dimensional analysis and its application. So these are few main topics that we are going to study in this chapter. Now, starting with the introduction part. Measurement is, again, as I said, is one of the most fundamental concepts in science. Without the ability to measure, it would be difficult for scientists to conduct experiments, note the observations, go for the conclusions, and also to form theories. Now, not only physicists or not only in science, but in farming, engineering, construction, manufacturing, chemical industries, other occupations, other activities, and even commerce won't be possible, or processes or things won't go easy without measurements. The word measurement comes from the Greek word that is metron, which means limited proportion, but metron means measurements. So origin of this word comes from Greek. Measurement is a technique in which properties of an object are determined by comparing them with a standard. Right? Now, on your screen, I have given two examples. Example number 1, suppose the first black dash is considered as 1 unit, and let us consider that much amount of length is our standard length. Okay. So what if we have 2 dash? So then 1 dash, if it is 1 unit, so 2 dash will be 2 units, right? So how we are comparing? We are comparing any measurement by any prefixed standard. Second example, 1 glass, I have taken 1 standard unit. So what will be 1, 2 and 3 glasses? I have put a question mark And the answer is very obvious. If one glass is 1 standard units, 3 glasses means 3 times the standard unit. That means 3 units. Whether it is marks of any test, quiz or exam or result, just now you have given a test or quiz of chapter 1, you got some marks, and those marks will determine how much you were able to give the correct answer. Measurement is also required in cooking, right? You cannot cook anything on a very high temperature. Even if you are taking proper medicine, it must be counted. For example, a 200 mg tablet is also there, a 500 mg tablet is also there. So according to your need, you will take that medicine. If you go to purchase anything, whether it is fruits, vegetable, clothes, footwear, etc., you will need some kind of measurements. You won't say the shopkeeper that give me vegetables, that's it. Even in sports, running, how world record is done? It is only done because we are doing measurements. The bowling speed, right? That Brett Lee bowls at 161 kilometers per hour, right? That exactly is measurement. How we come to know that Brett Lee is bowling very fast? By the measurement of the speed. Even the winning of any game is determined by measurements, right? Suppose you take football, so we are measuring goals, right? And those who are securing more goals, doing more goals, they win. Even in cricket, if winning is decided by runs or wickets, right? Operating machines also, like we have some measurements of the speed of fan, we have measurements for temperature of AC, temperature of microwaves, temperature of iron. Even you are charging the phones will show the measurement of the battery. Now telling about capacity, volume, amount, or even time, very important. You see, time is also measured. Talking about anything else which is more practical other than science, buying, selling, profit, loss, interest, everything needs some numbers, that is measurements. So in comment section you will mention your own examples. Don't forget to do the comment, right? Moving on, let us start with more important topic, that is physical quantity. We are doing measurement, but what are measured, right? There must be something that we are measuring. Just take an example of ruler. What we are measuring with ruler is length. So length is the physical quantity. Clear? So a physical property or some quantity which can be measured and described by a number is called physical quantity. Physical quantities are the building blocks of physics in terms of which basic laws of physics can be expressed. I will give you many examples. You see in different colors they are shown. For example, mass of a person is 60 kilogram, length of a table is 2 meter, temperature of the room is 300 Kelvin, time duration of match was 4 hours. So all these are nothing but physical quantities. Mass, length, temperature, time. What they are? They are some quantities, some properties that we are measuring. So those are physical quantities, and we will measure, or scientists measure physical quantities. Now, whenever you measure something, it is represented by the help of two important things. That is, one will be the number and then will be the unit. Number will be the magnitude, the intensity, the value of whatever you are measuring, and unit will be the prefixed standard measurement. For example, if height of a student is 162 centimeter, you can find two things. One is 162, that is the number value, and another is centimeter, right? So this means that if we take 1 centimeter standard unit, it is 162 times the standard unit. So 162 centimeter. Same way, if you measure the capacity, that is the volume of a water bottle, that is 750 ml, right? Again, mention these values mention these answers in which I have put question mark. What is the value and what is the unit? If the capacity of the water bottle is 750 ml, what will be the value and what will be the unit? Now, there are two types of physical quantities in physics. One is fundamental, other will be derived. So we'll start with fundamental. There are limited independent physical quantities which are used to determine other physical quantities. That is why we say them as independent, right? They are very limited, they are very few. So they are the most basic things upon which we derive another physical quantities. So that is why they are known as fundamental, right? And the units of these fundamental quantities will be fundamental units. Clear? Don't forget that quantities are different thing and units are different thing. So we have two definitions. Fundamental quantities, they are the quantities, and units will be the units of those quantities. In total there are 7 fundamental physical quantities. They are mass, length, time, electric current, temperature, luminous intensity, and amount of substance. Second type of physical quantities, they are derived. As now we know that we have 7 fundamental physical quantities. If we combine them in any proportion, or if we combine them, we will get new physical quantities, and those new physical quantities will be known as derived physical quantities. So that is why I have written they are very large in number. The more you go for the combination, the more derived physical quantities you get. Now their units are called derived units. Now let me clear it out. Speed is a derived physical quantity. Okay, speed is a derived physical quantity, but it depends on fundamental physical quantities. How? You see, speed equals to distance upon time. Distance is nothing but length. So ultimately what is speed? Speed is the combination of length and time, right? So length and time are fundamental quantities. Now what is the unit? So unit of speed is meter per second. The unit of length, meter, time, second. So meter and second called fundamental units. Length and time are fundamental quantities. But speed is derived physical quantity. Unit of speed is meter per second. Clear? Same way you can have another example like acceleration. Okay. So what is acceleration? It is length upon time square, meter per second square. So acceleration is a derived physical quantity which is made by combination of fundamental physical quantity. Now in general, scientists use a system of measurement which is still commonly referred as the metric system. Okay. Now what is system? System is the different set of many things. So system of unit are the set of basic unit that scientists were using to help in all kind of measurements. Okay. So system will compiled of many different units. In earlier times also in different countries different system of units were there. For example, CGS system was centimeter gram second. C for centimeter, G for gram, S for second. Centimeter is unit of length, then we have gram, unit of mass, then we have unit of time. Clear? So this was the French system, early system of unit. FPS system was foot pound second, that was British system. MKS was meter kilogram second, that was again French system. MKSA, that was meter kilogram seconds ampere. And finally it was international system of unit, that was again decided in 1971 World Conference in France. Why we were in the need of an international system? Because you can see, if Britishers were using foot as the unit of length, French were using centimeter. So if imagine if a Britisher will say give me 2 foot of a stick, French will tell what is foot. We don't use foot as the unit, we use centimeter. So tell me in centimeter. So British will be confused. I only know about foot. How can I know about centimeter? So we needed many conversions. So that is why, to create these kind of confusions in a very less manner, all the scientists of different countries, they united in world conference and they decided that we will consider few basic quantities, we will decide their units, and that would be the standard units all over the world. So that is why it is known as SI system, International System of Units. Clear? Now what they have decided is there will be 7 fundamental quantities and their units. In this table you can find the base quantity, name of the unit, full name, right, the word and the symbol of that word. For example, length is measured in meter and the symbol of meter will be small m. Note the difference in other units, some are capital and some are small. Mass we have kilogram, kg. Time we have second, small s. Electric current, ampere, capital A. Temperature, Kelvin, capital K. Luminous intensity, that is luminosity, right, how bright an object can emit the light, that is luminous intensity, that is measured in candela. The symbol is CD. Now amount of matter, the unit is mole and symbol is MOL. So I hope you are knowing 6 out of these 7. Luminous intensity, I guess you were not knowing, but it is a fundamental quantities. When we speak about optics branch, luminous intensity is important, right? So these 7 fundamental quantities, the name of the unit and symbols were finalized as the international standard units. Besides these 7, we have 2 extra units which are also known as supplementary unit. Now they are plane angle and solid angle. So you came to know that it is measurement of angle, right? Now if it is 2D, it will be plane angle. So that is measured in radian. In the bracket I have given the symbol. And if it is 3D, if you are measuring angle in 3 dimension, it will be solid angle. The unit is steradian and symbol is SR. Clear? Now we have some guidelines for writing the SI units, like few rules you can say to be followed. This is a very important question. Every year this question is asked in any of the exams. So take care of all the rules. In total we have 6 different small rules. The first rule is unit of every physical quantity should be according to its symbol. So unit and symbol must be matching. No full stop should be used within or at the end of the symbol of unit. For example, kilogram is written only as kg, k dot g or kg dot is wrong. Symbols for unit do not take plural form. For example, if we are measuring any length and it comes out to be 260 meters, but when we represent it, it will be 260 m, that is meter, right? So even if there are more than one standard comparison, for example, your weight might be 50 kilograms, but you will not write kgs, you will write 50 kg only. Next, units which are in numerator denominator form must be written in single ratio only. So if it is meter per second, second you take upside and its exponent will change, right? So even if we have meter per second, we will write it as meter second inverse, okay, single ratio. Now very important, full name of a unit, if it is after scientist, is not written in capital letters. Now this is where we are not following the rule of grammar, right? In proper noun, letters must be capital, clear? But if we are writing the unit of force, that is Newton, we will think that it is proper noun, start with a capital. No, if you are writing the whole word Newton, it will always be in small. But if you write the symbol of Newton, the first letter will be capital, only N will be capital, right? So last will be, but in symbol of that unit which is named after a scientist, first letter will be capital. Then if any letters are there, it will be small. For example, Newton only had one letter, that is N, so first letter was capital N. But in unit of pressure it is Pascal, so its symbol first will be capital P, and if we are using A, that will be in small. Clear? So only first letter capital in the symbol. If you are writing name of the scientist, only small letters. Clear? So these were the guidelines for writing SI units. Now that's it for today. Please fill the post session feedback form that is given in the description box. Till now we haven't achieved the 100% ratio. Clear? So every student must watch the video and fill the post session form, that is the Google form that I am giving you. Those feedbacks will help me in improving the quality of video. Right now I am not giving any questions as a part of homework. Just do the note writing work. See the video. Why I am doing this in PPT form? Because you can pause and write the notes. Clear? So that's it for today. Thank you.